So whenever you are looking for some Godot tutorials, you may find some that are pretty good. But in spite of that, sometimes they tend to be super simple and they don't really cover more advanced topics that you need in order to kind of take your Godot and game development skills to the next level. Some of these are, for example, inherited scenes, overriding functions, which is basically script inheritance. These are maybe not super advanced but still important because sometimes these tutorials use a lot of get parents and this is not a good practice, and a way of dealing with this could be groups, singletons, and even more ways. So in this video, we're gonna be creating a Godot game the right way using these more advanced concepts. So what I'm gonna do is that I'm gonna use this game that I have created a couple of months ago. So basically a game in which you collect these keys, okay? But also if you collide with some obstacles, as you can see, you start losing lives, and well, you can lose some lives until the game is over. So the logic itself is not that bad, but something that you will realize, for example, is how these objects that come from the sky are handled. So this is an area 2D, basically, that has an animated sprite with, well, the different frames. And this area, what has here is an enum with the type. So these types could be either a coin or an obstacle, which are basically assigned over here already. So I create a random index, and depending on this, I assign a selected type, so it's completely random. And then based on this, for example, we have here the body entered function. So if this collides with a player, what we do is, okay, we emit a signal of coin collided with player, or if we have collided with an obstacle, we emit a different signal. Now, of course, the logic is not that bad, but it could be way better, and for this we're gonna be using some of the concepts that I've mentioned, specifically inherited scenes, okay, and overriding functions, which is basically script inheritance. So inheritance both in scenes and scripts. So I'm gonna keep this object scene basically like this, and what I'm gonna do is I will find this scene over here. And what I'm going to do is right click on it and press new inherited scene. I will actually turn on the highlighter over there. And here it is. So how I'm going to call this one is basically object, okay? And I will put just a dash over there, and I will call this one coin. And I will save it with Control S. So here in scenes, I'll create a new folder, object, and I will put it there. And I will also save the object scene over here, okay? Then I will right click once again on the object scene, new inherited scene, and this one's gonna be object obstacle, okay? And let's save it over there, okay? So what this happens is that now we have a base object, and this, as you can see, can kind of override them. So in this case, both of them are going to be pretty similar in terms of the scene itself. It's going to be very similar. But just for you to know, let's say that we want to add an object to both the coin and the obstacle. You don't have to be copying and pasting stuff. You can just do that over right here on the base object class. So let's say that we want to add, for some reason, let's say a particle. Okay. So here's the particle, and as you can see, when we save the scene, it's gonna take effect in both the coin, okay, and the obstacle, okay. So basically, it's that script inheritance. So the data is shared between the children, okay, of the base. But I will just delete these ones because we don't really need to use them. Now let's open up the script, okay, and let's start analyzing some of the things. So first of all, this thing of the type, here we are assigning it randomly. We don't want to do this anymore. We want to assign this depending on which object we are, if we are in the coin or in the obstacle. So that is the first thing. But in order to do so, we have to take a look at script inheritance, okay? So what I've added here is a class name called myObject. So I will just actually call it, you can call it object, I believe, because there's already a class called object. Yes, class object has a native class. So yes, let's just call it base object. I believe this one should be, yes, this one is available. And what I'm gonna do is, like in the scripts over here, I will create a brand new folder first of all, and I will call this one object. And let's actually save this script over here, as we have done before. And then what I'm gonna do is create a new script over here, which I'm gonna call object dash coin, and another one which is gonna be object slash dash obstacle. Then in this script, what I'm gonna do is right here at the top, I'm gonna add the fact that it's gonna not extend node, but extend our base object, okay? And I'm gonna do this in both scripts. And like this, what you're doing is inheritance, okay? So what happens is that now all these two scripts have access to anything here. Just so that you can see it, let's say that, for example, we add the ready function. And here we can access whatever we want. So we can access, I don't know, the movement speed. If you type, I don't know, print movement speed, as you can see, I can access it. And if I do control click, I'm referenced back to this class name. So basically what happens with inherited scripts is the same thing. You can now access any data over here. So how is this useful? For example, because now we can assign the type manually rather than randomizing. So I will select all these, I will press Ctrl / just so that it is completely commented. And the same thing with random index. Is it used anywhere else? I don't think so. Yes, it's used here for the sprite frames. But well, for now, let's just do the type assignment. So what I'm actually gonna do is that, okay, yes, this enum can be there, that's good. But the selected type, what I'm gonna do is make it export, so that I can assign it directly in inspector. Then another thing, here's where we're gonna be using inherited scenes. The base object directly, I believe, yes, we'll have the base, the object script, but the object coin, I'm gonna deattach this from here, and I'm gonna attach the coin. Okay, and from the obstacle, I will deattach the base object, and I will assign the obstacle. What's gonna happen is that now in the inspector, I am seeing here, for example, the sprite frames array, because this is also an exported variable over here, but I also have the selected type. So the obstacle is gonna be of type obstacle, and the coin is gonna be of type coin. Okay, so that's perfect. So there you have the first thing. Okay, so now we are not assigning these randomly, we are assigning them directly in the different scenes. Okay, that's it for now. What else can we refactor? The next thing that we can refactor is the animated sprite. So what happens here is that, if you remember, here we have an animated sprite with different animations, okay? But in reality, we have some sprite frames, as you can see, that should be saved somewhere in the project. I don't really remember where they used to be. Resources, sprite frames. So this is the coin sprite frame. So everything related to coins, keys, whatever they are. And here we have the obstacle, okay, which is a little bit different. Now, I didn't really had to use an animated sprite, but anyway, it was kind of simpler in that time. And here I was basically just selecting a random sprite. So how exactly can we redo it, okay? Because once again, here we used to have a sprite frames array, okay, which here used to have the two sprite frames that I showed you. So right now what we want to use is just basically use one of the sprite frames and just play a random frame from here, okay? So how I'm gonna be doing it is the following way. So sprite frames array, we don't really need an array anymore. We just need one sprite frame array. So let's do it sprite frames, and let's call this one sprite frames. There we go. And here already, what we wanna do, here we had animated sprite frames. Let's just maximize this. Animated sprite of sprite frames is equal to a random index here, but in reality here, we just want to do the animated sprite dot sprite frames. It's gonna be equal to the selected sprite frame. So sprite frames, okay, assigned over there. And then here is basically randomizing which of the frames to play, basically here which of these ones to play, basically selecting a random sprite. I know it could have been better to load an array of sprites, for example, but well, it was made like this and there is no need to refactor that. So now if we go to from this is the obstacle, we have to load in the sprite frames. So obstacle and then coin, there we go. Perfect. And there we have this done as well. What else do we have? Now we have here the movement logic, which basically moves down and rotates. So this is common for both objects, so we don't really have to modify it. And here what we have is the function that is called when it has collided with the player. And basically, once again, depending on if it has collided with a coin or with an obstacle, it's gonna do something. Now this is not bad, okay, but it could definitely be better. So what I want to do is to create a function that then is going to be able to be overridden. So in reality, these functions are usually started with an underscore. Let me actually enable this option that will allow me to scroll down a little bit more. So let me actually find it over here on behavior, scroll past the end of file over here. So that's why they are usually started with an underscore. In reality, on body entered, process, all these are what are called virtual functions that then can be overridden because they already have default behaviors. In reality, if you do control click on process, for example, here you have like the, well, not the original function, but what it does. But as you can see here, it says virtual. So it's basically that. So I'm going to call it underscore on object collided with player. Okay, it's gonna return void. And here I'm gonna be able to basically write the logic, okay? So what I'm gonna do is that, okay, the common behavior here is that they're gonna be always queued free. So I'm gonna always leave here. I will always queue free them. Okay, so I can delete this. And the other thing that is done is, okay, that depending on the type, we are emitting different signals, okay? So one way of dealing with this would be, okay, if the body is in group player, okay, we basically call on object collided with player. And now what we're gonna do is copy this function name, and in the children, let's type the same name. And what we're gonna be doing with this is an override. So in reality, if we type it in, we should be able to see it. So on, let's say the changes before on play. Okay, yes, we're not seeing it for some reason. Auto completion sometimes doesn't work, but you should see it. There you go. Okay. So over here, what we can do is pretty interesting because we can type in super between parentheses. And what super with the parentheses is gonna do is firstly call the function in the super class or the base class. The base class is also called super class. I personally don't like that name. I prefer way more base class. It's way easier, but what it's gonna be doing is basically that. Okay, first of all, calling what we had in the super class, okay, which in this case was base object. So first it's gonna be queued free. Now, first of all, I would like to emit the signal, okay, and then queuing free. So we can do that. So here, if we are in the coin, we want to emit this signal. So let me just copy this line and I will emit the signal and then super. Once again, how do we have access to this signal? Because we are extending base object, okay? Then let's do something very similar, but in the obstacle. But here we're gonna be emitting obstacle collided with player, okay? Now, and here, what do we do? In these lines over here, we can just delete them or comment them, okay? As simple as that. So now this logic is mostly done. However, probably this will have some problems with other things in the project. Yes. For example, here, this is not anymore my object. This is base object When I had like a lot of problems, but I will show you how to troubleshoot them. This is once again base object. Let's go again. This is not my object. This is base object. There we go. Okay, here it is working, but here when it wanted to assign something, oh, but this was in our object, so let's see what went wrong. Cannot call method get animation names on a null value. So the sprite frames or the animated sprite, but where has this been assigned? Already animated sprite. Okay, let me check this error over here. But in reality, the problem does not come from the logic, but because here what used to be spawned was the base object all the time, because we only had one scene. But in reality, yes, we have here object scene, but in reality, now we want to instantiate one scene or the other depending on probability. So it is kind of different. So what I'm gonna do is create here object scene array. And it's gonna be an array of packed scenes. Okay, now here we're gonna be having some problems. Object instance, I'm gonna do object scene array dot pick random dot instantiate. Okay, this pick random is amazing. It basically allows you to exactly do that, pick a random item from an array, so pretty straightforward. And now what we'll have to do, this is the object spawner timer over here. We have to basically add these two elements. So I'm gonna be adding the object coin and the object obstacle. Okay, and now maybe we have more problems in other places, but let's just check it out. Or maybe this just at work. Okay, so we have no problems. Let's check. Okay, here we are losing lives. Here we can collect some coins, so that's amazing. Okay, we keep collecting coins. There, sweet. And then yeah. Okay, there it is, game over. So, pretty interesting. And with this, basically, we've seen mostly all concepts. So we've seen inherited scenes. Okay, that's amazing. We've also seen overriding functions. Okay. And we didn't see directly groups and singletons, but we want to see how this actually managed in the project, because it's actually pretty simple. If you have understood the previous things, this is a piece of cake. So maybe you remember that how these things are managed. Basically, the collisions are with the signal. So how do these signals actually work? Because, okay, this signal is emitted, but which are the receiver methods and objects? So first of all, we have to understand is that these obstacles, when they are spawned, they are basically nested inside this objects container. We can actually see this if we play it and go to remote. As you can see, they are basically instantiated over here. Let me pause there. So what happens is that, remember, okay, when we collide with these objects, what we want to happen is that, okay, they are deleted first of all. And not only that, but also, for example, we update the UI. Why can't I see the UI over here? Well, I think it's because it's paused or a Godot bug, whatever it is. So we kind of have to do different things. So how exactly does the canvas layer node, which is over here, know that this object has been collected? So what some tutorials show you is, okay, do get parent, then get parent, and from here get the canvas layer. That works? Yes, it works. But what happens if then you don't want anymore this objects container to be here? You just want to instantiate them in the scene itself. You don't care about organizing your hierarchy, which is completely fine. Or something else changes. So once again, you want to make your code as sustainable as possible, and you don't want to make it vulnerable to hierarchy changes. So one of the many ways to handle that is with signals, okay? You can also do it with groups and also with singletons. I will just go over some of them. I personally like using signals. So what happens is that when a new object is instantiated, here, this is a timer. So on timeout, here we exactly do that. We instantiate an object, we add it as a child of the object's container. And here we do the different logic, and what we have here is another signal which is called object instantiated, and what it has a parameter which is exactly that, the object instantiated, the object instance. So this is emitted. So we are sending this message with the information of the object that has just been instantiated. And this is listened in the canvas layer. So this is connected via the inspector, if I am not wrong. Yeah, this is connected here by the inspector, as you can see, to the canvas layer, exactly to this function, okay, that is showing over here. To this function, okay, it looks a little bit weird because originally it was like this, but it was kind of long, but this is the correct name. So on object spawner timer object instantiated, why this name? Well, usually receiver methods of signals start with the on keyword plus the underscore, and then you have the class name or the script name. So in this case it is object spawner timer, so object spawner timer, which is once again the one that emits the signal. And then you have the signal name, in this case object instantiated. Okay, so when this happens is that we start listening to both signals that this object has. So coin collided with player and obstacle collided with player. Once again, this is what we have seen over here. And here we basically connect them to some receiver methods, which as you can see look very weird because of the super long name, but this is something that I personally recommend a lot, is that these names are super descriptive, okay, and you understand exactly what's going on. So once again, in this case is on object instantiated, because this is, well, this is not the class name, it should be base object, but I put on object instantiated because it was the name of the variable or here of the parameter, so that's why. On object instantiated, coin collided with player, and this is exactly what happens when we have collided with the player. So what we do is increase the score, update the score label, and play an audio. Okay, and when we collide with an obstacle, it's a little bit more, maybe not complicated, but we have more things. So we decrease the lives if lives are equal to 0. So if we have no more lives, we show a UI, we play as an audio, we pause the game, and we basically return. So that this doesn't get executed. Return is just, okay, exit. Do not execute this. What we do here is basically just delete the lives, okay, the life that has been lost, and then we also play another audio of that live has been lost. Okay, so it seems complex. It is not. This is the one of the many ways of making a robust system. So the key takeaways that you have to know here is that, okay, whenever you want to have a base object, okay, try not to centralize all the logic in just one script and do 100 if checks over here to determine the type. In reality, I believe in the code, we are not anymore using these types, literally. We've removed them from here, we remove them from here, so it would be completely safe to directly delete this enum and delete this exported variable that we did before. But once again, for other cases, this could be pretty useful. So that's the key thing. Whenever you start to see a code in which you have a lot of ifs, elifs, for determining the type of an object, for example, if you have characters or players of different types, there probably is an amazing opportunity for you to start using inherited scenes, which as you can see are super related to also inherited scripts, because in every single opportunity that you use inherited scenes, probably you will also need inherited scripts. Okay, and that's the main thing. And then whenever you want to kind of try to connect things that seem completely impossible to be connected to each other, signals are one of the best ways of doing it super organized. Now I want to discuss the last way, okay, of having to connect this with signals, which is a little bit more straightforward, a little bit simpler even. I am not probably going to be implementing it just because I don't think it's worth it, because you can do it like that, but I don't know, it has its downside, which is using groups, for example. So what could happen is that in order here for you to quickly reference this canvas layer, what you could do is add it to a group. So you can do it like this. And what you do here is have this exact same receiver method. So or something similar. So coin collided with player and obstacle collided with player. And then in your object here, or actually in the instances over here, rather than emitting the signals, what you would do in reality here in the object, what you would firstly do is create an onReady variable, which you would call, in this case, canvas layer. I don't know if this has, no, this doesn't have a class name over here. So I will just add one. I will do it with you here just because I think it's interesting. I will just call it my canvas layer, for example, because I cannot call it canvas layer because it's an already made class by Godot. Now let's go to the object over here, canvas layer, and this is my canvas layer, and this is gonna be equal to get tree dot get first noding group canvas layer. So now I have directly a super easy way to reference this canvas layer. And the only thing that I really have to do, we can forget, for example, about these signals. So let's do control/ to comment them out. Then here in this, we are gonna be having errors, as you can see. So when we collide with this, we still want to do it like this. But what I want to actually do is, okay, call the canvas layer, but call a specific function from the canvas layer. So over here, what I want to do is, you can see I'm receiving an error here. I want to still execute the superclass, but here what I want to is to access the canvas layer. Once again, I can access it because it is inheriting base object. And I can do dot, this is the coin. So the function was pretty normal. It was something like on coin. And basically this one, on object, spawner, timer. No, this one, it wasn't this one. Let me go back to the canvas layer. And basically this one. So let's copy the name, paste it over here. And there it is. And let's do something similar, but with the obstacle. So this is for the obstacles. You can see here we decrease the lives and all that. And let's do canvas layer dot all this. Okay, of course the name could be shortened in this way because it's not anymore a signal. It could just be obstacle collided with player. And with this, the logic is completely done. So as you can see now, we don't have any more to, for example, in the canvas layer over here, let's save the changes. We don't have to anymore be using the signal over here, or basically the signal that used to be here either of, okay, object instantiated. We don't have to be using this anymore because everything is kind of automatically handled. So now we can play, and if everything was okay, as you can see, we should be having no errors. So this still increase the score, whereas these ones basically make us lose a life. So once again, once that you start to understand these concepts, you can start building on top of them. And it's pretty interesting, okay, because you are now able to write way bigger code sets and bigger games, okay, with all these concepts. So I hope that they have been helpful. Now, if you like the way in which I explain things, something super interesting that you can literally get access to all my game development courses, of course, including code courses, 1 month free and 60% off your first month directly on Skillshare with this link over here. So it's pretty interesting. Once again, 1 month completely free. So it is a lot. And here you get access to literally with just one subscription to literally all my courses. Okay, so that's pretty interesting. As you can see, I have 7 courses published at the moment there. Or if you want to get them individually, you even have them in Udemy. So here you have like Godot courses, ChatGPT course, Unity course, so literally a lot of things. So for example, in this course in specific, you have this game that we use as an example, how to make it completely from scratch and all that. So I hope that you take this amazing chance of learning Godot for a very, very low price and discounted price. Okay, so I hope we can see each other in the next one. Bye bye.